So we're going to take another step now back into the optical transport infrastructure, right? Go back a little bit from the upper layers to the real work, physical layers, and how actually automation and how, SDN NFV-enabled infrastructure can look like to support our next businesses on 5G, mobile edge compute, and so on. All right, here it is. Okay, great. So the industry is very, very busy at the moment. We have so many standards: ONF, ONAP, CORD, OpenNFV, MEF, you name it, right? So many things are going on. Data center principles are being introduced into carrier networks because the operation is significantly more cost efficient. However, carrier networks have different requirements than data center players, right? We have to support synchronization, WAN protocols, optical layer awareness, right? Physical layer awareness, network ORM, multi-site connectivity, right? Transmission of data, and so on and so forth, right? To implement this IT-like operation, open APIs, SDN, white boxes into carrier environment has, certain requirements to be met also in carrier networks, right? So how are we going to do that? So things that is happening is that purpose-built platforms have been virtualized. Now they're hosted on servers, right? Nothing special. We all know that. I like that because it's very analog to our, smartphones. I have one smartphone, but I have a lighter in it. I have a calculator, I have a music player, I have a watch. I have everything on the smartphone in the meantime, right? So this is really a new, let's say, not a new, but it's a technology evolution that is helping carriers and operators to deploy services much more quicker, much more cost efficient in the networks, not dealing with all these different hardware systems that you need to deploy that are proprietary, right? So as the next step, we have seen disaggregation. We have seen open line system and open transponder system being introduced into the market. The same here is innovation, acceleration of innovation, right? So open line system enable faster innovation of, dedicated transport network capabilities. Open transponder, disaggregated transponders are enabling next generation of transponders much quicker than if it would be, let's say, a packet optical transport system that includes all these different layers into one box, right? And this openness is important because we also now support in this disaggregated network elements open APIs, right? So that can be, as I mentioned in the beginning, integrated into IT-like operations, right? So you can integrate open, disaggregated transponders and line systems significantly faster in your network, right? The same is happening with routers, right? We have seen, you can visit EdgeCore downstairs, for example. They have open standard-based hardware, white boxes, that support, standard process forwarding engines and a variety of NOSes. So they are actually independent of the software. We are disaggregating the hardware from the software, and the software is portable. You can deploy actually software now into any open hardware, into any COTS equipment, right? And some of the IP functions actually you can host in the cloud, right? Because now from the cloud you have better visibility of your network. It doesn't have to sit on individual network elements and they see only their neighbors. If some IP functions are sitting in the cloud, they can actually see the entire network end to end. So this is also eliminated the vendor lock-in, is also, of course, accelerating innovation cycles. And on top, if you deploy such a system in your network, how big should the router be? 5 terabit, 10 terabit? You don't know, right? You don't know today how fast the traffic will grow. We all know it will grow, right? So you need a scalable system, right? And in order to scale, you can actually leverage IT-like operations, data center player operations. They used spine and leaf architecture to scale networks, right? So, and a router is nothing else like they have a central fabric and they have port cards. The central fabric is the spine, and the port cards are utilizing the backplane to talk to the fabric cards, right? And now with this approach, you don't need to install day one a big router and they just have 2 or 3 cards sitting in it, because you want to be ready for the future, right? You can actually deploy the leaves and spines and connect them with physical optical line interfaces to scale your network. So actually you pay as you grow, but also you power as you grow, right? So each of these devices, the leaves that you are installing, they actually, only deploy them when you need them, right? They are not sitting around and waiting until, they get occupied. And also, the leaves can also be stacked. So we support, for example, with our system, a stacking of boxes so that to reduce the number of, IP addresses, right? So you can manage 15 terabit of routers in 3 boxes that are stacked together, for example. And this is adopted by the industry very quickly. This is an IHS report that shows that core infrastructure will be deployed by major operators. There are initiatives from AT&T and open source projects and Google's and South Korea Telecom and Verizon. You see also disaggregated NOS driven by AT&T. So this is happening. Yeah, disaggregation is happening. We already have NFVs. Now let's put this into perspective. Let's put all these components into a network. We all know about multi-access edge compute. I actually tend to say mobile edge compute, it's easier to say. What it does is we need to support newer applications, right? NFVs are emerging, 5G is coming, AR, VR, IoT services are coming. We need more bandwidth, we need more devices to manage. We need lower latency applications as well. So what we do is basically, or what mobile access edge compute is saying, we are moving the cloud closer to the edge of the network. What this really means is we deploy compute power, servers, closer to the edge of the network to host the content closer to the end user so that we can reduce latency, right? And what are the applications that support those? This is SD-WAN, virtual BNG, virtual CPEs, virtual CMTSs, intelligent video analytics. So we can host now applications closer to the end user. Yeah. What are the benefits? Is the improved performance. You have lower latency, right? You have a better performance on your applications. You reduce the latency. You reduce the backhaul cost. Because now the services, they don't need to be backhauled all the way to the core site where the content is stored, right? They can be just backhauled to the next MAC site where the services are hosted, right? So it's significantly reducing backhaul cost and offer new differentiated services that, for example, AR, VR that requires low latency. However, to deploy mobile edge compute has a lot of challenges we need to solve. Power, you need more power at the sites, you need more cooling at the sites, you need more space, and even noise is important at the edge of the networks. So these are the challenges. And there's one thing we can do to address these challenges. Just one thing is needed. And this is the next slide. It's really about liquid cooling. We have it downstairs, so I think a couple of you guys have been already seen it. There's a new liquid cooling developed. Liquid cooling is significantly better than air cooling. It provides better heat density than air, and it helps you to reduce space and power. Right? So if you look at the right, you see the air cooling 1.7 is the power usage effectiveness. So this means 70% of the power in data center is used just to cool equipment, just for air cooling. Liquid cool provides 1.05, so just 5% would be required to cool the data center. Just 5%. This is huge. This is really huge. This new liquid, I mean, it has been, liquid cooling was a concept already discussed a couple of times back in the years, but this one is really non-toxic, non-allergenic, non-flammable, not harmful, no corrosive, biodegradable. You can touch it. It doesn't harm you. It's a single phase. It doesn't vaporize, right? So this liquid is really now enabling liquid cooling in data centers. You don't need, like Microsoft, to put your data center into the ocean, right? We can bring it much, much significantly cheaper into your data centers immediately. The savings are tremendous, right? Here's an example. We have our router sitting and the smartphone operating in the fish tank. Standard router sitting there with fans running and a smartphone. You can see that it's still running. Here is another Dell server that is put it in a tank just to showcase it, right? And HP and Dell and Supermicro, they support this technology, right? They provide you guarantee. The liquid has a life cycle of 20 years. You don't need to change the liquid within 20 years, right? And you have guarantee for 10 years. You have warranty on the liquid in your environment. So liquid cooling, disaggregated components. Now let's put everything together. This would be a perfect platform for multi-access edge compute, right? It helps you to reduce power, space, to address the noise issue and the heat issue. There's no noise. You can come down. We have exactly this liquid pod sitting in our booth. You can see it, you can hear it, and we can have further discussions. So what is the value of Infinera, right? The servers are coming from Dell. The liquid is done by our partner, Engineered Fluids, right? So what is the value? We are adding these building blocks, disaggregated components, with the servers, with the liquid cooling, and with SDN management, right? We manage those, and we make it deployable into your networks, right? So this would be a typical, let's say, embracing openness with the network solution that supports deployment of such an infrastructure in the network, right? We will utilize the Infinera Transcend Maestro orchestration to provide end-to-end service provisioning, monitoring, slicing management, programmability of such a network, and even automation, right? We are utilizing the NFV Mano to provide NFVs in this network so that you can apply your desired NFVs in your network, right? So, this is just an example. You can deploy it at the edge of the network, at the aggregation side, and even at the core side, right? You can use this liquid cooling everywhere. It enables you to deploy compute power in any location. So let's look at the software suite. So if you have we have a building block architecture. So we have an orchestrator, we have SDN controllers, we have our network management system, Mano, but this is all interchangeable, right? You don't have to use our orchestrator. We support open interfaces that you can use your orchestrator that you're familiar with. However, our orchestrator provides additional values. We have a pod computation engine, we have virtual pod controller that we can control the pods, and we have Adapt. Adapt is an automation tool that is helping you to organize your network significantly better and automate it. Let's spend a few words on the Infinera Adapt. 2 weeks ago, we have this just done a couple of weeks ago, introduced this in a network automation. You can see this as an example. The total number of packet drops has been significantly decreased. You can see no packet drops anymore because we are utilizing information from the cell side and rerouting the traffic automatically. In the panel Jutta just discussed, this closed loop automation is reality today. We can deploy today. You don't need any additional services. You can, services. So actually, we have been looking. So in the middle, you can see the utilization of the different links. 100%, 33%, 78%. So it was not balanced, right? With an automation tool, we can significantly better balance the network. And it's automated. And it will react to changes automatically. So we can balance the load in the network significantly better with the software suite, right? So we just talked about infrastructure that we are deploying with mobile edge compute, and then an SDN software-enabled control of such an infrastructure together with automation, right? This is what Infinera brings to the table. And the success, as you see already, the first results are really great. Here's another example how we manage, for example, such an environment. Often operators need to deal with the different vendors all the time, right? With disaggregated transponders, PONs, leaves, servers, fabric switches, whatnot, right? We put as a single network element. You see here an example, I think that's the laser, So this is basically a Helsinki site, and if you open the site, you can see the spine switches, you can see the leaf switches, you can see the servers, and the VNFs that are running on the servers. We can provide alarm management on each of the different systems so that you can locate the fault significantly easier. So we really make this solution deployable, right? Taking these industry standards, open initiatives, and taking the next technology wave, using liquid cooling to address some of the challenges, manage them together with a single entity, and enable operators to deploy such a solution in the network. Right? So it's reality. You can deploy today. You can see it, you can feel it, you can touch it. I really invite you guys to come down to the Infinera booth, very close to the exit area, and you can see the liquid pod here. Right? So you can see here the servers that are liquid cooled. These are the fabric switches. This is an open transponder. Here is the liquid cooled, the pumps that are pumping the liquid through the servers. And this is the liquid pod that will sit in an outside container for deployment. And you see here how it looks from the backside. Each server blade has its own manifolds and hoses so that you can replace also servers if required. And this liquid is enabling actually a better lifespan of a server because it is removing fans, right? And there are no hotspots. Liquid is a significantly better cooling mechanisms than air, right? And actually, if you go the next step, you can design servers significantly better now, having in mind liquid cooling instead of air cooling. So if you design a server today, you have always in mind air cooling. You have hotspots. You need to leave the area around for air to flow out, right? But now with liquid cooling in mind, you can change the board design of a server, for example, right? Again, Dell, HP, Supermicro, they all support this liquid, and we have server blades sitting here that are supported. You can choose your server that you want, and you can deploy it in your network. Right? It's reality, it's there. So I hope I give you a good idea how you can deploy mobile edge compute or multi-access edge compute in the network significantly better from a transport perspective. Okay? Thank you for your time. If there are any questions, we can address them. We have 2 more minutes. All right. Thank you. Okay.